Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design. Today day 4 autonomous vehicle design introduction topic, and in addition to that we will discuss in detail about that MATLAB Simulink experiments, how we can configure the DC motor or motor with MATLAB Simulink. Right? Am I audible? Can you please confirm? Dear participants, am I audible? Dear participants, you just confirm, am I audible? Am I audible? I welcome you everyone here. I welcome you everyone here. Am I audible? Dear participants, am I audible? Yes, thank you. Thank you. Thank you very much. Thank you for your reply. Right. This is Malaypan from pantechelearning Private Limited. About Pantech. Pantech is an educational equipments manufacturing company. From Pantech, you can get lab equipments for EEE, ECE, computer science, IT related products. You can get it. Our vision is to help the students to learn the technology in easy way. So far, we have trained about 20 lakh students. And today topic is about autonomous vehicle introductions. So here we will discuss autonomous, because actually in this nowadays the autonomous vehicle is it's a highly interesting area. So if you are new to this electric vehicle design, so you just know about the basics of autonomous vehicle, how and that what are all the types of vehicle and all. And finally we will discuss about the MATLAB examples. Right, so are you ready to learn these technologies? Are you ready to learn this content? If you are ready, please comment in the comment box. If you are ready, please comment in the comment box. If you are ready, please comment in the comment box. Ready to learn. I'm just waiting for a comment. Thank you, Mr. Tukita. Thank you, Mr. Rockstar Vijay. Thank you, Mayvale Nishantini. Yes, thank you. Yes, thank you so much. See here, if you are autonomous vehicle, if you talk about autonomous vehicle, so which means that it's going to be computer on the wheel. So simply we can call it as a software defined vehicle. So now see, actually you can configure the vehicle with any kind of programming methods. So on that manner we can call this vehicle system as a computer on wheel or else software configured vehicle. So whatever it is, we can configure it on very easy manner. So for that the electric for that that AI will help you lot. The AI will help you lot. Right. So here the types of autonomous vehicles. So very first stage is called no automations and the driver assistance, and then partial assistance and conditional automations. So like that we can classify that one. So if you go in detail about the types, in detail about the levels, so generally in the industry the people will call it as a level of autonomous level of system. So let us take that level 1. So here in addition to that existing vehicle, so that the small automation may comes into the picture. So which means that the adaptive cruise control or land keeping assistance. So see, actually here if you take the cruise control, I think many people may aware of that cruise control, which means that we can synchronize the vehicle 1 speed with vehicle 2 speed. Right, so that we can automatically the speed will get controlled with the help of, with the previous vehicle. So or else we can detect, we can control, we can control the vehicle on the same land. So either this facility or that facility only has been introduced as a automated manner. So that's why we are calling it as a level 1. So here the driver is must to do other functionality. Same way for the level 2. So here so in the level 1 either only one function is included. So in the level 2, so both the function has been included. So adaptive cruise control as well as the land keeping assistance. And in traffic area, so the automatically the vehicle will get assisted for the driver. And for remaining functions, the driver is mandatory. For remaining functions, the driver is mandatory. Same way for the level 3. So here in the level 3, that the parking has been automated. So the parking, that is which means that the traffic autopilot for the parking system. At the same way for the traffic jam also, right? And here the driver can take little bit rest but not completely. The driver can little bit rest but not completely. Whenever the intervention is required, then the driver should assist the vehicle. But whereas in the level 4, so here little bit more relaxation to the driver. So here for the defined map, the vehicle can run automatically. So wherever it requires the stop, wherever the object detects, then automatically the vehicle can operate automatically. Right, and here the driver may take some rest, but it not completely. But there will be some there is some risk involved. Whereas in the level 4, so this is completely autopiloted mode. So here the no driver required. So up to level 3, level 1, level 2 in the market, many vehicles are available. Whereas the level 3 and level 4 still it requires a lot of research to reduce the accident. Whereas the level 5 still it is in the research mode, completely in research mode, not in the commercial mode. So we hope within another 2 to 3 years, up to level 4, you may get a vehicle in the market. And we cannot the level 5 also, it may not take much time, definitely in 2 to 3 years. So all the levels of the automated system may be hit the market, so it will be in our hand. So that's why we are calling this vehicle automated vehicle. It's called as a software defined vehicle, or else we can call it as a computer on wheels. Right. So now, what are all the essential parts to do the automated vehicle system? So first one is that computer vision concepts you must know, and sensor fusion. See, because sensor fusion nothing but it's a there are a lot of combinations of sensors which we are going to use. So for that one, the sensor, one or more sensors needs to be placed on a vehicle to cover, to provide the 360-degree view. So which means that, so actually in any direction the object may reach to the vehicle. So in that situation we should cover, and as well as that we should generate a control signals to the vehicle. So that's called a sensor fusion. So one sensor output needs to be added with the another sensor output. And the localizations. The localization nothing but see here, what are all the objects, what are all the lane it's available on the position of the vehicle. So that's called the localization. For that sensors, radar sensors are required, and the GPS sensors or LiDAR sensors also required. And the path planning. So of course, if you tell that it's automated vehicle, the vehicle should know what is the starting point and what is the end point. So for that the path planning is required, and the control. So the control will help us to the control will help us to reach the vehicle on the desired destination with again with the desired speed and then directions, everything needs a control, right? So here in this 30 days masterclass, we are going to learn how we can control the motor, how we can control the vehicle in all the aspects, right? So you should learn you should learn the entire basic concept, then you can easily understand what are all the essential parts required, right? And see here, so what is available in this MATLAB? See here in the Simulink, there are for four, these are all the mandatory toolboxes to implement the automated systems, right? The very first one is that Simulink. So here we can develop map, and we can develop the algorithm, and we can verify the algorithm. Whereas in the SimScape, we can include the physical parameters also into the picture. And the automated driving toolbox will help you to integrate all the type of sensors, as well as the object, traffic signals, everything. And then the road runner will help you to automate the vehicle, to integrate all these things into the single model. So these are all the important and the essential toolboxes to implement the automated vehicle systems, right? So now, so actually from this MATLAB, from this EV design masterclass series, so similar kind of prototype you can develop. So for that one, we have given the detailed blueprint of this prototype with this block, with this masterclass. Whereas in the real-time internship model, we can support you for the four-wheeler, complete full-fledged four-wheeler system also, right? Those who are all interested, you just comment in the comment box. So real-time, physical internship, wherever if you want to get a physical internship, you just comment in the comment box. Our team will help you, and you may get real-time vehicle assembling as well as the disassembling of the EV, and you can take a road test also, right? So let us come to the vehicle, electric vehicle. So here the electric vehicle may have different mechanisms like a series, hybrid, other things. So here how we can generate a control signal for the automated system. See, for example, if you take this block diagram, so here this is the electric energy storage. So here the motor will receive a control signal to the mechanical transmission. So which means that so already in yesterday's class also we have discussed about that PWM, right? So whatever you develop all the control algorithm, finally the algorithm going to generate a controlled PWM only. So the PWM only going to decide the motor is going to operate or not. So depends the duty cycle of the PWM that we can operate the motor, right? So now again, in addition to that, the directions. So directions, we will use the servo drive to change the directions. There also the PWM may require, right? So here, the PWM denotes that this is the control signal. So this is the control signal, right? So the PWM is directly proportional to the drive signal, or else drive signals. So this is directly proportional to the load power. So here the load power denotes that instantaneous power. So the instantaneous power. So here the instantaneous power nothing but whenever the motor speed is high, then the PWM will be high. So due to that, the power will be high. So whenever the driver applies the brake, that time the power will get low. So first the driver will get low power, apply the low power or brake, then the PWM will get 0. At that time the power will get reduced in the motor. So here we can call it as this is dynamic power, this is the average power. So dynamic power is nothing but it's an instantaneous power. The average power, if you take average of the signal, then we can take it as an average. So here we can from the graph we can easily understand. From the graph we can easily understand the instantaneous, that is called the dynamic power is nothing but the drive signal. So here the motor will generate the average power. So if this is a constant value, so suppose if it is the repeated value, so from this we can take an average, right? So from this we can take an average. So by implementing some circuit, then we can take average power. So from the average power, the motor will generate a power. I will show you with the demo example how the power can be defined with the MATLAB Simulink, right? So here we can apply the similar kind of electric system to the IC engines also by implementing series as well as that hybrid method, and series and hybrid method also available. So this is generalized power transfer, power transmission to the vehicle systems. So now for our EV system, battery, vehicle power, and then motor. So here here only we are going to apply a PWM as a drive signal, right? Here only we are going to apply a PWM as a drive signal, right? So now how we can generate a control signal to the motor. So for that one, you should know the power electronics concept. So you should know the power electronics concept. So what is the power electronics? So the power electronics is a simple electronic circuit. With that circuit, we can generate a controlled output voltage. With that circuit, we can generate a controlled output voltage, right? So for that controlled output voltage, we can so we can apply any kind of to any kind of the load, right? So again, in the MATLAB you may get a drive cycle generator. So it's again automated automotive forum has given some standards. So what is that standards, where how long it should be high, how long it should be low for the automated lab test. So that block also available in the MATLAB Simulink. So I will show you how you can integrate all these informations into your MATLAB. So just engage with the session. I will show you some example. From that you can easily understand how that automotive vehicle can simulated with this MATLAB, as well as that how we can develop a control logic for the PWM. So for that I will show you some two different examples. So which means that see, if you want to count the vehicle speed, right? So how you can measure the vehicle speed? So there will be a sensor called the speed sensor. So that speed sensor may be a magnetic sensor or pulse, optical sensors. So from that sensor we can get a square pulses, right? So we can get a square pulses. So now by counting this number of pulses, we can identify the RPM. That is, which means that suppose if you keep one sensor, so the one revolution, one positive pulse and one negative pulse, these two the entire pulse with the period, it's called as a one revolution, one rotation. So here the rotation per minute. So how long it's going to take? So if you measure this time period by applying this pulse to the microcontroller, whenever the pulse is high, the microcontroller interrupt will get high. So and that time the counter will get enabled. Once the pulse completed, then the counter will get reset. So we can take a counter value. That counter value will give you the time period between the starting of the rotation and end of the rotation. So from that we can calculate number of pulses, how long it's going to take, right? So for that I have introduced that counter design function and the drive cycle scenario, and one more example also I have introduced, that DC motor, how you can configure the motor power and how you can estimate the speed and how you can assign the speed. Right, so all these things we will discuss one by one. So please engage with the entire session so that you can easily understand, and you can, if you are new to the MATLAB Simulink, then this example, if you implement based on this video, if you implement this example by your own, then definitely you can crack the MATLAB Simulink. I hope you understood the point. So if you have any questions, you just comment. I will try to give you the answers. I will try to give you the answer. And one more thing. So tomorrow, tomorrow is the last date for joining the internship. If you are interested, then you please join into the internship. Right. So tomorrow is the last date. Tomorrow is the last date for joining in the internship. The link is available in the chat box. So you just have a look. If you are interested, you can go ahead. Right. I will show you the MATLAB demo. Right. So so first let us try to calculate the pulses, number of pulses per minute. Right. So just open the Simulink. So create a new model. And as we know that the square pulses is required. So for the square pulse, just select pulse generator. Yes, just select the block called pulse generator. Right. So pulse generator. So now we can run this one. So for we can run this simulation for 1 second. A pulse width should be 1. Alright. So we can keep this pulse width as a 50%, and then period is 1. So which means that if you run this simulation for 10 seconds, so the 10 pulses may appear. Right. So the 10 pulses may appear. So now what you have to do? So just add this one. Take a memory block. Yes. So just to take a memory block like that, you have to take. So take a memory block and just add this one. Take a sum block. Yes. Just to take a sum block. Now straight away just add this one. Just add this one and rotate this block and add here. So now here just take a counter or a scope. Just to take a counter and a scope. Yes. Sorry, not a counter. This is a display block. So how many pulses may appear, like that we can measure it. Yes. So just run this one. So now we have to do some small simulation solver setup. I will tell you one by one. So since see here we are generating a square pulse for 1 second, right? So in that case, so just open the simulation solver setting. Just open the simulation solver setting. Here just select solver. Selection is about fixed step, and take solver details. Yes. So here what you have to do, the sample time must be less than the 1 period of the cycle. So here we can keep it 0.5 or 0.6 as a 1 sample time, right? So we can keep 0.6 also as a 1 sample time. So just save this one. Just save this one. Yes. So now we are running this simulation for 10 seconds. Okay, so now just try to apply this one. Just change that one. Fixed step. Yeah, see here. See here. So the counter initially the first pulse has been included, and then second pulse, third pulse, fourth pulse, up to 10th pulse it has been included. See here, so the square pulse is a continuous signal. Okay, so the square pulse is the continuous signal. So in that case, so the square pulse is a continuous signal. Since we are running the value for 10 seconds, if you are running the value for 9.9 seconds, then what, let us check, this value will be 10, right? So just a second, we can verify. Yeah, so now it shows that 10. So by adding this graph, you can easily understand. By adding this graph, you can easily understand what is the input and then what is the number of values which shows that. Now you just compare. Yeah, see here, this is the pulse 1 and this is the pulse 2, pulse 3, pulse 4, pulse 5, pulse 6, pulse 7, pulse 8, pulse 9 and pulse 10. Okay, so after that, actually here we run the entire simulation for only 9.99 seconds. If you keep on running the keep on running the simulation, then automatically the pulse will get counted. So here the maximum value is about 10. But if you increase this simulation time, then keep on, it will get added. So this is the pulse generator block, and this is the adder block or summer block, and this is the memory. So here the functions of the memory is nothing but, so whatever the value available here, that will get added. So because here we are applying only instantaneous value. So for very first time, so initially the memory will be 0. Memory will be 0, and whenever the first pulse applied, here the output value will be 1. So at the same time the memory will get updated. Right. So at that time, here output here the value will be 1 and the pulse also will be 1. So now the 2 will get 1 and 1 plus 1 will get a 2. So again in that time you may get a 2 value, right? So this is the second value. So like that, at that instant the memory block also will get updated. Right? The memory block will get updated. So for that on that instant, just a second, yeah, on that instant, so that the process keep on will update. The process keep on will get updated. Right? So the process keep on will get updated. So by this method, this is the simple logic. Same way you can do in the hardware also. So this logic automatically, will work for for your hardware also. Simply, actually in this simulation I have included one session in the last 23rd, 24th session, how you can implement the Simulink into the hardware. That also I have included. So please try to engage with the entire series so that you can explore all the technology. If you have any questions, you just comment in the comment box. I will try to give you the answer. If you have any questions, you just comment in the comment box. I will try to give you the answers. Yes. Do you have any questions? If you have any questions, what is the memory block? So why you use it? So the memory block is the block to store the previous value. The memory block is to store the previous value. If you have any question, just comment. Mr. Pulkit George, the memory block is to store the previous value, previous data we have to store somewhere, right? So for that the memory block is used. I hope I answered the question. Any other questions? If you have any other questions from this example, how to certificate received by see, after the series we will generate a certificate and we will send you the email. So by verifying to visit our website, then you can get a certificate. Why we are seeing this much diagram? See, these are all the small concepts which we are going to integrate in the EV system. How to import files in MATLAB. That is depends the type of applications. Just in case I will show you in the forthcoming examples. Yeah. After internship career support program from here. Yeah, Mr. Ajit. If you want a career assistance, you just come call me after this live. I will try to give you the clarity. I will try to give you the clarity. After this live, you just call me. I will try to give you that clarity. Do you have any more questions? Do you have any more questions? Yeah. For internship, you should pay Mr. Sajit. Yes, Mr. Manmohan, how to import files shared by you in MATLAB? See here, I just go to a open block. So just go to open block. Click the open folder. Straight away you can open in this Simulink. Straight away you can open in the Simulink. Like that you can just open it. Then you may get a you can get an active file. You can get an active file. Yes. Straight away we cannot connect without the memory block. We cannot connect because there is, somewhere we should store the block value. Somewhere we should store the block. Yes, Mr. Gladys, we can implement the script also. So some experiment actually in the PMSM motor control. We are I have shown you one example to integrate the script model. Yes, Mr. Shankari Vamsi Krishna, you just follow this 30-day series. Definitely you will get a clarity, complete clarity you will get. Yes, Mr. Vijay Sharma, you can start your internship from the Monday. So till Monday you can join everywhere. Is there any exam conducted? No, there is no any exam. Maximum speed and minimum speed I will show you in the next example. Yes, thank you. So shall we move to the next one? Yes, so now let's move to the next example. Drive cycle scenario, already we have seen that one. If I saw that experiment, definitely will take time. So I will show you this experiment. So the DC motor controlled by the voltage, and then we will configure you. So just wait. Go to the new simulation. Take a DC motor. Right, just to take a DC motor. So this DC motor comes up with a physical model. This DC motor comes up with a physical model, right? So here we can apply a battery voltage. Here we can apply a mechanical constants. So now let us take a DC voltage. Just to take a DC voltage. So now let us take a 1 HP motor. So here we can configure the value. So by rated power, rated speed, and the no load speed, right? So here no need to do any inductance value. So you can check the no load speed and then rated speed. So which means that no load speed will be higher than the rated speed. If you take rated speed is about 5000, I mean 4000 RPM. Right, so the no load speed will be more than that, so you can keep it, you can define the value. So like I'm just going to keep 5000 RPM. And the rated power, so here what will be the rated power? Mechanical power. So like if you take a 1 HP, right, so let us take 786 watts, right? So 786 watts we can claim. And then DC supply, rated DC supply voltage, we can apply 100 voltage. Right, we can apply a 100 voltage. So just apply this one. So here we have configured 1 HP motor. Here we have configured 1 HP motor with 4000 RPM as the rated speed, and then no load speed will be the 5000 RPM. Right. So the no load speed will be higher than the rated speed. And we have to apply a 100 voltage. Yes, okay, right. Let us keep the 100 voltage. You just connect this one. Okay, actually I took the different block. Just to take a DC voltage source. So this is the physical model of the Simscape block. Yes, this is the Simscape block. So you just connect positive and the negative. So here in between we will introduce the PWM block, right? So that is the power electronic circuit. After again from tomorrow onwards we will start the power electronic circuit, how we can control the thing. So now the 100 voltage straight away it's going to apply, but in actual case it will not be. So in between we will introduce one more circuit. That circuit will have a PWM control. So while you change the PWM, then we may get a different voltage. I will show you one by one. So you don't worry, don't panic. I will give you on step by step. You don't worry. From this, if you complete this 30 days, definitely I assure that you can become a EV engineer. You can become a EV engineer. Right, so now we have to connect again, so we cannot keep the motor in air, right? So we have to mount the motor, we have to keep somewhere in the laboratory. So for that one, you just arrest the vibration things and all. So for that one, that this is the sensor module, and this is the mechanical reference frame. So just add this block, take a mechanical rotational frame. So just connect it. Now we need a sensor, right? Mechanical rotational sensor. So from that one we can measure the speed. So we have to measure the speed. See that this is the reference frame. So mechanical sensor we have to take. Rotational sensor. Just search sensor. Yeah. Ideal rotational motion sensor. So this is the ideal rotational motion sensor. So now you just connect it. Yes. So this is the motor. With this block we can measure the speed of the sensor, right? So now just to take a PS2 Simulink converter, right? So just PS2 Simulink converter, just to keep, this is the, here we can connect the, here we can connect the gearboxes and all. So now at this moment we are not going to load the motor. If you want to apply the load, so here we can apply a load. But at this moment we are just keeping this as an open end. So that is called no load test. right? So this, since we are going to measure the speed, so the rotational speed we have to take. So for that one, here the radian per second will be the rotational speed. So just to take this one, radian per second, right? And take a scope block. Take a scope block. Yes. So now everything has been connected. Now everything has been connected. So since all these components as a Simscape component, so we have to include that header file. Solve. Simply we can understand this as a header file. So just include here, and here electrical reference we should include electrical reference ground plane. We have to add at this moment, right? So 1 HP motor has selected. So for this 1 HP we have defined the speed. What is the full load speed? What is the what is the maximum rated speed? So these speeds we this speed has been configured. This will be we are going to measure the speed. We are going to measure the speed, right? Right. So here we'll try to solve this one. Just try to run this simulation. Yeah. So okay, right. So we taking much time. So the motor should run at no load speed. Okay. So just to change the unit. Here the value. Oh my God. Okay. Motor not connected properly. Second, I did some mistake. I don't know what I missed. Just a second. I'm just trying to. Just a second. Just a second. Let me check. Okay, yeah, here we missed the value. Nothing done. What I did. Everything perfect, 100 voltage. But why the speed? Oh, right, okay. Here we missed that 100 voltage we have not applied. Just try to apply this one. Now I just run this for 1 second. Just run this for let us take this one. Just run this for 2 seconds. So let us try. I will show you one by one. Please engage the class. Just engage the class. Yeah. See here now about 5000 RPM. It's keep on running. Right, the source value, that radians value, so radian per second, we have to convert this value to the RPM. So by default, so if you want to measure the RPM, just take a gain block. So whatever the value comes, my God, just a second, let me remove this one and connect. Yes, So here this value will measure the motor speed, physical parameter of the motor, and so this will give you in the radian per second. So from radian per second to RPM conversion, just apply 30 divided by pi. Just apply 30 divided by pi. So now you can get a RPM value. Now you can get a RPM value, right? Yes, now you can get a RPM value, right? So now you can run this one. So the rated no load, no load speed we may apply, we may get. So now here we can apply the total vehicle weight. So here we can apply the load to the motor. So in that case, we may reach the rated speed, or else we may reach the load speed based on the conditions, controlling method of the DC motor. I hope you understood. If you have any questions, see here now the value exact shows that 5000 RPM. The value shows that 5000 RPM. So here if you apply the PWM in between these two circuits, the instantaneous voltage will be applied, right? So in that case, the instantaneous power also may require. Instantaneous power also may generate. So by applying the PWM, at the end of the the motor speed generated by the motor, so this will be the average speed. This will be the average speed. So this will not this will not reach zero or maximum at instantaneously by when you apply the PWM with respect to the PWM. But the average power the average power will be applied to the motor. Due to that, we can control the speed. We can control the speed, right? I hope you understood. So I will enable all the block parameters. Just a second, I will enable all the block parameters so that yes. So this is the DC motor block, and this is the mechanical rotational reference. Just take. And this is the ideal rotational block. Yeah, this is the electrical reference. Just to take a note. Yes. And this is the solver configuration. Just enable, I'm just enabling the format, show name, yes. And this is the DC voltage. And this is the scope. Just to take a screenshot, practice by your own, then only you can follow my experiments. Then only you can follow the experiments. Else you will end up with a problem. So try to engage, try to complete these two experiments today. Then tomorrow we will go to the power electronic concepts. How we can introduce the PWM between the motor. Do you have any doubt? If you have any doubt, you just ask me. I will try to give you the answer. If you have any doubt, please give me. If you have any doubt, please ask me. I will try to give you the answer. Yeah, three-phase is available. Three-phase block sets are available. But block sets are available. You don't worry. Yeah, all the concepts I have included related to the EV system. You don't worry. Definitely, I will give you all the answers. Attendance link, don't forget to submit the attendance form. Please submit your attendance form. Don't forget to submit the attendance form. Do you have any questions? You just ask me. Thank you so much, Shankar. Rolex, please explain the functions of all the parameters. See here, this is the DC voltage source. So here we are applying 100 voltage because the rated motor voltage is about 100, right? So now we are applying the rate. How you can purchase the motor? You should tell the motor power, you should tell the speed, and then you should tell the rated voltage. If you apply here 200, then input also should be 200. So this is the mechanical power, 786 watt, and then 4000 is the rated speed, and this is the no load speed, 5000 rpm, right? So here simple connections. This is the electrical reference, and this is simply you can understand this is like as a header file for the Simscape components. So wherever you are using the Simscape component, you should use this solver configuration block. And this is the sensor block, because in the real time we will use the mechanical sensors like a magnetic sensor or optical sensors to identify the motor speed. So same way in the MATLAB Simscape you have an option to measure the motor speed by implementing ideal rotational motion sensor. And this is the mechanical rotational reference frame, because so this block we should keep somewhere, right? So since we are taking the mechanical physical component, physical parameter, so for that one we like electrical reference, this is the mechanical reference. And the simple PS to Simulink converter. So here we have to here we should mention the physical parameter unit, right? So physical parameter unit. So this is the gain block. Yes. So this is the gain block. Whatever the signal comes into the line, so that line, that signal has been multiplied by 30. Multiplied with 30 divided by pi. So now you may get a RPM value. Now you may get a RPM value. I hope you understood, Mr. Yes. Rolex, I hope you understood. In block parameters of DC motor in electrical setting, I am getting the armature resistance and inductance. Why the difference than your case? Just open the motor. Just open the motor. Here just select model parameterization. Here just take if you know the equivalent circuit of the motor, you can apply. Or else you have only the torque and the no load speed. Here also you can apply. So I know the motor power, I know the rated speed and the no load speed. So by this method you can configure. Simply if you change the value, then you may get a, just change this option, you may get this different type of blocks. What is PI? That 30 divided by pi, which that is conversion from radian per second to RPM. That is the conversion of radian per second to RPM. Which package we have to download to do this simulation? Just take a 2023 MATLAB or 2022. Anyone? While you installing the MATLAB, don't forget to check all the blocks. We have to apply the load at this point. We have to apply the load at this point. I will add the simulation with the next class. I have a that example also. So try to engage with the session. Tomorrow is class there. Don't forget to submit. Don't forget to submit your attendance. Tomorrow also class scheduled. Right? So many people are asking that keep on in YouTube. You can attend the free masterclass. If you want to get a participant certificate by email, you should pay the processing fee as 100 at the end of the series. Whereas in the internship, we will give you the recorded classes. You can access that class for 60 days, and you can download the MATLAB Simulink project files. And since so far we are using only the examples, From power electronic project concepts onwards, we will give you the project files. So there you can use that project. If you want to develop your by your own, definitely it will take a long time to build the project. But if you use this project, definitely you can complete your academic research. So it's very, again, the cost is very less, and in addition to that, you will get a support if you are if you are having any clarifications. Here I am help you by WhatsApp as well as the Zoom class, right? So just to take this one, tomorrow is the last date. Tomorrow is the last date. 2nd 7 2023 is the last date for joining in the internship. So this is the last option. So you try to get into this one. Attendance link is in the top of the chat. You just check. Thank you, Mr. Rolex. If you have any questions, you please ask me. Yes, Mr. Yuvraj. Exactly. Speed sensor is used to calculate the DC speed. How to control speed through PWM? Definitely, I am for forthcoming. Next session schedule we will discuss in detail about that one. Engage the entire series, Mr. Harish. Omkar, we not received the last day's PPT. Yes, all these PPTs will be shared by Monday. Since the today and tomorrow people will not be available, so by so I hope by Monday you will get all the PPT. Exactly, Mr. Sridhar. Speed sensor is used to measure the DC motor speed. PPT will be shared next mail maybe.